Hey everyone, I hope you're doing well. This video is going to be an introduction into partial fraction decomposition. The goal is for you to eventually be able to rewrite a rational expression like this into two partial fractions like these. While this exercise may seem a little bit strange, this skill will be very helpful when you're solving integrals in calculus. While my next video is actually going to be writing these partial fraction decompositions, the goal of this video is to help you practice rewriting rational expressions in partial fraction decomposition form. It's important to know that in each of these partial fractions, the degree of the numerator must be 1 less than the degree of the denominator. Since the degree of the denominator is 1, the degree of the numerator is going to be 0. Since x to the 0th power is just 1, we don't need to write it. Here we can see all the other linear denominators that just have a constant in the numerator. In this case, since x squared is just a repeated linear denominator, it also has a constant of b in the numerator. And for these last two partial fractions, they both have quadratic denominators, meaning they both must have linear numerators. Besides keeping track of degrees, just keep in mind that you also keep track of repeated factors. Now let's get into some practice problems. Here in example 1, it looks like our denominator is already factored. This x here is linear, and this x plus 5 is linear. Decomposed, this will take the form of a over x plus b over x plus 5. This right here is our partial decomposition form. While I'll go over how to find a and b in the next video, the objective of this video is just to get this form. Let's try example 2 now. Here we have a linear factor of x, but keep in mind it's repeated. And over here, we have a linear factor of x minus 5. Whenever we have a repeated linear factor, we need to include each power of that linear factor. So we'll have over x, and we're going to have over x squared. Our last partial fraction here is going to have x minus 5 in our denominator. On top, we're just going to have a, b, and c. Here's our partial decomposition form. Let's try example 3 here. Here's a linear factor, and here's a quadratic factor. For a linear factor, we're going to have a over x, and for a quadratic factor, we're going to have bx plus c over x squared plus 6. Since we have a quadratic denominator, we need to have a linear numerator. This is our partial decomposition form. And here's example 4. Looking at this denominator, hopefully you notice that this is going to be a difference of squares. After factoring our difference of squares, we're going to get 4x plus 1 in the numerator over x times x plus 3 times x minus 3. We factored our quadratic into two linear factors. Here we can now see that all three factors in the denominator are linear. From this, we can write a over x plus b over x plus 3 plus c over x minus 3. Here's our decomposition form. The key takeaway from this example is to see if your quadratic is factorable or not. Let's try example 5 here. Notice right away that we have a quadratic denominator, but that it's factorable. Factoring out the GCF, we can get 5 over x times the quantity of x plus 2. Now that we have linear factors in the denominator, we can rewrite this as a over x plus b over x plus 2. This is our decomposition form. Let's try number 6 here. Factoring the denominator, we're going to get 4 over x squared times the quantity of x minus 5. While each of our factors in the denominator are linear, keep in mind that our factor of x is repeated. From this, we know we're going to have one denominator of x, another denominator of x squared, and our third denominator is going to be x minus 5. Since all our denominators are linear, we can just put a, b, and c on top. This is our decomposition form. And here's example 7. In this problem, we have a linear factor of x minus 3, and it's repeated 3 times. Since we have a repeated linear factor, we're going to have our first partial fraction be over x minus 3, our second one be over the quantity of x minus 3 squared, and our third one be over the quantity of x minus 3 cubed. Whenever we have repeated linear factors, we have to include each power of it. Since they're all linear, we can put an a, b, and a c in the numerators, and the sum of these gets us our form. There's our answer. Here's example 8. Since our denominator is factorable, we're going to rewrite this as 2x plus 3 over x times the quantity x squared plus 8. Now that we've factored, we have a linear factor of x and a quadratic factor of x squared plus 8. Since x squared plus 8 isn't factorable, we're just going to leave it alone. Our two partial fractions are going to have a denominator of x and a denominator of x squared plus 8. Since x is linear, we're going to have an a on top, And since x squared plus 8 is quadratic, we're going to write bx plus c in the numerator. The sum of these partial fractions gets us our decomposition form. Let's take a look at example 9 here. While we can't factor anything in the denominator, notice how x is a linear factor and x squared plus 2 is a quadratic factor, but it's repeated. The first partial fraction is just going to have an x in the denominator, the second partial fraction is going to have x squared plus 2, and a third partial fraction is going to have the quantity of x squared plus 2 squared. Since x is linear, we're going to have an a in the numerator, and since the next two partial fractions have quadratics on bottom, we need to have linear terms on top. We have bx plus c here, and dx plus e here. The sum of these partial fractions gives us our decomposition form. Example 10 here is going to be our last problem. Notice from the beginning that we can factor out a GCF from our denominator. Rewritten here, we're going to have x squared minus 3x plus 2 all over x squared times a quantity of 4x plus 11. Here our x squared is a repeated linear factor, and 4x plus 11 is also a linear factor. In this example, we're going to have three partial fractions. The first one is going to have an x in the denominator, the second one is going to have x squared in the denominator, and the third one is going to have 4x plus 11 in the denominator. Since each of the denominators are linear, we're going to put a, b, and c in the numerators. The sum of these partial fractions gets us our decomposition form. And that wraps up this video. I hope you found it useful in just getting the decomposition form down. In my next video, I'll go over examples where we're solving for the numerators as well. If you found this video helpful, please let me know in the comment section below. Keep up the good work, and I'll see you in the next one.